Have you ever stared at a spreadsheet just packed with numbers and thought, okay, is there a story in here somewhere? Well, you're in exactly the right place. We're about to go on a journey from just a pile of raw data to an actual discovery. Think of this as the big picture overview, the why behind all these powerful statistical tools before you get bogged down in the nitty-gritty details.
So here's our game plan. We'll start with the fundamental problem that every single researcher runs into. Then we'll look at how to organize our first clues. From there, we'll actually test our hunch, unlock 3 essential keys to a really deep understanding, and finally learn how to tell the complete story with our data.
All right, let's dive right in. The first and honestly the most important challenge we have to tackle is what I like to call the analyst dilemma.
Okay, picture this. You've surveyed, say, 1,000 people, and you notice something interesting. People with college degrees seem to answer a question way differently than those without. That's a pattern. But, and this is the big question, is it a real, meaningful difference that applies to the whole country? Or did you just kind of lucky and happen to survey a weird random group of people? That's the whole ballgame right there.
And that's really the heart of it, isn't it? I mean, it's pretty much impossible to survey everybody. So what do? We take a small slice, a sample, and we try to figure out what's true for the whole population based on that slice. Statistics, well, they're the tools that give us the confidence to make that leap. To say, yeah, the pattern I'm seeing here is very, very likely a real thing out there in the world.
So how do we even start looking for those patterns? Well, our first tool is all about getting organized and just taking a first peek at the clues. Let's talk about crosstabs.
Don't let the fancy name cross-tabulation scare you. Seriously, a crosstab is just a simple table. It's built to do one thing, and do it really, really well. Show you the relationship between 2 different things at a glance. It's like sorting all your data into different buckets, so you can easily see what's going on.
So here's a crosstab in action. It's looking at the link between education and opinions on gun permits. Now, there's a key rule for setting these up. You want to put the cause, what we think is doing the influencing, our independent variable, in the columns. In this case, that's degree. Then the effect, the outcome we're measuring, our dependent variable, goes in the rows. Here, that's opinion on gun permits.
So here's the crucial trick to reading this thing. You compare the percentages down the columns. Let's look at that favor row and just scan our eyes across. See that? Only about 70% of people in the less than high school column are in favor. But that number shoots up to almost 84% for people with graduate degrees. Boom! That's a pattern. We are officially on the trail of our first clue.
Okay, so we found our first clue, a pretty clear pattern. But that takes us right back to our big dilemma. Is this difference real, or is it just a fluke in our little sample? To figure that out, we need to bring in the big guns and officially test this relationship.
And for that, we have the chi-square test. This is our statistical detective. The way it works is actually pretty cool. It calculates what the numbers in our table would look like if there were zero, zilch, no relationship between education and gun law opinions. Then, it just compares that imaginary, no relationship table to the real one we actually have. The bigger the difference between the two, the more likely our pattern is the real deal. And this is what the result looks like. I know, it's a lot of numbers, but don't worry, we only need to focus on one little number here. See that box labeled chi-square tests? The number we care about is in the sig column. That stands for significance, but you'll usually hear it called the p-value. This one number holds the answer we're looking for. In our case, the p-value is 0.000. Now, in the social sciences, our magic number, our line in the sand, is usually 0.05. If our p-value is less than 0.05, we can start to get excited. And, well, 0.000 is definitely smaller than 0.05.
So what does that actually mean? A p-value of less than 0.05 tells us that there's less than a 5% chance that we'd see a pattern this strong in our sample if there was absolutely no relationship in the real world. We're basically saying we're confident we're not making what's called a type 1 error. That's claiming a relationship exists when it really doesn't. So we can plant our flag and say, yes, the relationship between education and views on gun permits is statistically significant.
But hold on, don't pop the champagne just yet. Getting a significant result is not the end of the story. In fact, it's really just the beginning. To truly understand what's going on, you need to unlock what I call the 3 keys to insight.
These 3 keys are direction, magnitude, and significance. Okay, we just figured out significance. Yep, the relationship is probably real.
But we also need to know its direction, like who is more likely to favor the law. And we need its magnitude. Just how big is that difference anyway? Is it huge? Is it tiny? You absolutely need all three to avoid jumping to the wrong conclusion.
Let's look at some bad examples. Here's a flawed interpretation that only uses direction. It sounds pretty dramatic, doesn't it? But what this statement conveniently leaves out is the magnitude. When you actually dig into the data, the difference between men and women is only 3.3%. So yeah, the direction is right, but the story is totally incomplete. Okay, now, here's a mistake that focuses only on magnitude. The difference is 2.0%. Great, but a 2% difference in which way? Who has more confidence and who has less? We have no idea. Without direction, magnitude is just a number floating in space with no context.
And this is the most common trap of all, focusing only on significance. The relationship is statistically significant. Okay, that might be technically true, but this is a huge pitfall. Just because a finding is statistically real does not mean it's practically important. The effect could be so incredibly tiny that in the real world, it's basically meaningless. So, the goal is to avoid all those traps by weaving all three keys together. Let's take a look at what a truly masterful, complete interpretation actually looks like.
Now this is how you tell the complete story. Notice how all the pieces are here. First, it gives the direction. Males were slightly more likely to report confidence. Then, it gives the significance. Yep, the relationship is statistically significant. And finally, and this is so important, it adds the crucial magnitude. The overall size of the effect is quite small. See? That is a complete, honest, and truly insightful conclusion. You know, a lot of the time, the best way to tell the full story is with a great visual. A simple bar chart like this one does a beautiful job. You can instantly see the direction. As education goes up, so does support. You can get a feel for the magnitude just by looking at how different the bars are. And since we already know it's significant, this one picture makes your complex findings super easy for anyone to understand.
So, let's wrap this up. Here's your takeaway toolkit for this whole process. You start with crosstabs to find the clues in your data. You use the chi-square test to confirm if those clues are pointing to something real. And you use the three keys, direction, magnitude, and significance, to interpret what you found and tell the whole story, not just a misleading little piece of it.
And that brings us to a final thought. Research is a journey that really never ends. We've established the significant relationship between education and views on gun laws. But what's next? What other factors might be part of this story? Could it be income, maybe political party, or where someone lives? One good analysis always leads to more good questions.